operational phase by lowering the risk and saving cost and making sure you have a smooth running, safe operation. So I split it up in four pieces. The first one I said I called it start at the end, and then validate the engineering data, so you make sure you have a solid engineering basis. Doesn't make any sense to build a house on a foundation that's a little shaky, because at one point in time is going to be falling over or sink in the ground. So it is very important in this whole concept to have a solid and consistent engineering basis that then can be used in engineering. And then I'll give you some examples when the engineering data goes to work at the operational phase from some customers, to give you some ideas. I'm sure there are many more, but maybe it sparks up some ideas in your head. That hey, that's not a bad idea. And then last, I'll talk a little bit about the information access, and like Eva said, we'll make hopefully some time for some questions at the end. Now, ARC issued this little chart that I found personally very interesting, that said basically what's the reason, the factor of shutting down a facility, a plant, and you see equipment and you see process, but the biggest part of the pie is people, 42%. That's kind of interesting. I don't believe anybody gets up in the morning, go to work and say by himself, okay, let's shut down the plant. That'd be kind of fun. It's just the fact that we need to empower the people at the plant with the right information. Right? I say information or data, because to me information is the data in context. That's very important, to have that information in the context of the task that you are performing. And I think I know for sure that we can definitely lower that 42% number, because obviously that's not a good thing. Here you see some other numbers from ARC, very interesting, that of course the biggest revenue loss is of course from operator error. And like I said, it's not intentional, it's just that not having the right information at the right time, and with that making not the right decision. And you see 60% of the operational downtime is caused by delays of finding stuff. Even I as engineer, I know that I spend a lot of time finding stuff, and that's kind of not fun and boring. You want to have it quickly there and spend your time on the real work you need to do, either engineering or operating the plant. But you see tremendous cost is involved when you of course shut down a plant. If you ever on average 7 shutdowns, unplanned shutdowns, that's terribly costly. So we definitely need to do something about it, and I think we can do something about it with this engineering design basis. Now you have to start at the end, like I said. So in this case, the end is the beginning of engineering, and if you see this little pie, then the biggest parts are of course constructing and buying the equipment. That's where the most of the money goes. But you see, for some people, like surprisingly, a very small part is actually used in engineering and design, and engineering is also like a 6%. But there, in that small part, you already determine how this plant is going to operate, how this plant is going to be maintained, and the safety and all those very important aspects that are so important when you operate the plant. So you have to start to be able to do the operation right and to save cost. There you have to start at the end, and you have to think about these things early on. Of course, the challenge is that these days these projects are very complex, and some of them are very large. I've seen projects like LNG plants that has 2,000 P&IDs. It's a huge facility in the Middle East, and for an owner-operator to check all this data and all these P&IDs in these fast-track projects, they seem to go faster and faster every time, is just a challenge, and it is almost impossible to do that by hand. And I talk a little bit about how a computer can help a little bit with that goal to make sure that you get what you want, not only to build the plant but also to actually operate the plant. And there are a lot of standards. The good news I always say about standards, there are many of them. It's not only design practices, it is safety practices, it is also practices from customers. Like I took this example, Shell is Dutch company. I'm Dutch, so I feel some relationship with them, and they have what they call the DEP, design engineering practices, and that's their way of, putting the design together based on their experience, their best practices. They're also wanting to make sure that once it is put together, that it is not only engineering sound, but it is also operation sound. Of course, they have many, many years of experience, and they feed it back to that design practices. And actually, you need in the early phase, you have to validate your design against these practices. So there's a whole stack of paper, and there's a whole bunch of these things to check for the design against the design, and that's a challenge. That's a challenge. But like I said, I'll talk a little bit about how we can maybe help with that challenge to make sure that you have a solid engineering basis and can have the benefits of that in operations. Now, starting at the end is also making sure that you ask early on what you want as owner, and owners do that, and one of them is Saudi Arabia. I work with the Saudi Arabia company for many years, and I think they did the right thing. It's a smart thing to very, very early upfront, before you basically let the project, to tell the EPCs, what you want at the end. Because sometimes, you create like a P&ID, or you create like instrumentation. As an EPC, you only have one objective, and that is, get enough data to buy, install, and maybe commission, and that's it. But of course, then after that, the owner takes over, and maybe he wants some additional information that he thinks is important and can help him in the operational phase. But if you don't ask, you don't get. And if you ask after the fact, it's going to be very difficult and or very expensive. So that's what I said, start at the end, make sure that you define it up front. It's a lot cheaper, and it's a lot better, and it will get you the engineering information in the end that will help you in the operational phase. So I want to get your opinion about what I just said. So we have a little poll question about what you think. So Ashley, maybe you can execute the first poll. We have two of them. Later one more to see what you think about that.
Thanks, Frank. Yes, everyone, please select the answer that best applies to you. Is finding the right information in context a challenge? Yes, we have challenges with accessing up-to-date information, or yes, but we will find it, it just takes longer, or no, we have it quickly and correct, or you don't know. I'd like to remind everyone that we have a question and answer session at the end of today's webinar. Eva will ask those later on, and I'll give everyone a second or hear more to vote. Okay, so I'm going to close this and share the results with you. So 42% of you said yes, we have challenges with accessing up-to-date information. Another 42% said yes, but we will find it. It just takes longer. 8% said no, we have it quickly and correct. And another 8% said you don't know. Back to you, Frank.
All right. So, like I said, it doesn't make any sense to. It seems to be, by the way, that the majority has, experienced this challenge as well. I heard it from many people, of course. I experienced it myself, like I said, in engineering, that finding the stuff is difficult, and then not only finding the stuff is one thing, but finding the information that is the right is also, of course, a challenge there. So talk about, getting the information right is a little bit about, validating and checking the data. So I told you about this little pie earlier, that small part is actually engineering and design, and actually from that small part is an even smaller part, like 2% on average with this slide, which is an older slide, but I also find that it conveys a real truth, when you execute a project, is that only a very, very small part is used in the front-end engineering and design. Yeah, and believe it or not, in that very early part, you have the greatest, 30% opportunities to actually not only influence the cost, but also influence the way that you execute this project and what kind of, process, what kind of, method you're going to use, layout you're going to use, safety, HAZOP studies are conducted. So that in that early phase is so important. So you have to really be early on there with making the right decisions, not only for the engineering construction part, but also for the operational part. Again, ARC had some things to say about it. That if you're not timely and early on plan the right thing, then later on you will find you find yourself in pain and with an initial risk. So, like I said earlier, you have to start at the end and not think about that after the fact. Just kind of lessons learned from my side. The same is this domino effect. If you make some assumptions, that's engineering is about making assumptions early on and then refining it till you finally have the final design and that you're going to implement. So there will be changes, of course. There's never, I don't think ever a project will be executed that everything is right in the beginning and then you go one time through this whole workflow and be done. No, there are iterations, but of course you want to minimize this rework and iteration, so make the right decision early on. That's the trick, and not have this ripple through effect, or at least minimize the ripple through effect there. So basically what we need is we need some kind of a system that can read these designs, the P&IDs, instrumentation, what have you, like an engineer, but then automate that. Because when I was an engineer, we basically glued the P&IDs together and we had them on a roller board and we just rolled them backwards and forwards, and like you see in the picture, everybody's leaning over it and scribbling on it, and you can do that with a couple of P&IDs. But when you have like 2,000, it's going to be a lot of scribbling and take a lot of time, and by the time you're done, the next version is there and you can start all over. So we knew somehow to capture that information, capture that data, and automate that checking, at least for the bigger part. So we want to check on the topology, the data, the visual, the drafting stuff, like the right labels and symbols, because in the end, these deliverables, it's not only the P&ID, I just take that as an example, but they'll be printed and somebody has to read it, even if it takes it in the field. He wants to know if this valve is car sealed open or not, and that tells him something about how to maintain that and operate that particular component. And of course against the standards, like I said, there are many of these things, and also your own company practices and standards. So for instance, I have this little example, it's very, very simple, but you see this pressure relief valve configuration. All the piping and everything is hunky-dory. Now you have to basically test that pressure relief valve to make sure that the setting is right, it operates right. It's a safety instrument, so it needs to be correct. But little problem, if you can see, there is on the top line, there is a drain missing, so they basically cannot isolate and drain it to safely test it. That's a problem. It can cause in people say, okay, I'm not going to test it. That's going to be later maybe a safety issue, so you don't want that. So you want to make testing and checking up front that yes, this valve is there, and we can actually do that, and we can automate that for you to make sure that the design basis is right. So if the operator goes in there and want to do the testing, then yes, all the components are there in the right place to do his work. And of course it can also be done, I took the P&ID since that's such an important component or important document for the plant, but same thing for instrumentation, it's also very important. Check if you have the right cables for thermocouples, for electrical, if you have the hand switch when you do lockout, tech out, what to put your hand in the pump when somebody can switch it on. That's not very healthy, and have the right enclosures with respect to area classification and so on. So you can check that early on, so you have the right stuff, and not only within the task, within the disciplines, but also across the disciplines, like across process, the P&ID and instrumentation. Make sure you have the right valve, the right line sizes, the right process data to have a consistent data there for later on if you want to do some maintenance or replacement of that component. Now the cool thing is, and everybody these days is asking for dashboards, so that's very fashionable, I guess. So we also show you here a little dashboard, and it's obviously that red is not good and green is good. But nice thing is when you're at the plant and you have done some of these checks against the design, because there's always changes during the running of the facility, so you can do this check in the EPC side, but also at the owner-operator side. You can actually click on one of those little tiles and navigate to see reports, and also actually a picture of, hey, what is actually wrong there? Can I live with that, or can I not live with that, and fix it? But the thing is that you have all this information on your fingertip, and it's coming from one single source, rather than, I have a P&ID, my own P&ID in my desk that I marked up for the last 5 years, but somebody else has the same P&ID in his own desk that he marked up for the last 5 years, and guess what? They'll never be the same. So once you have the engineering design basis then created, you started at the end, you have defined everything, you have everything in place, and now you want to use it. And I'm going to give you some examples. So, of course, you want to reduce the risk, safety, and make sure that the guy has the right information to make the right decision, and not fall in the category of the 42% that accidentally pulls a wire or something to shut down the whole plant. That's bad news. I understand that engineering systems are like P&ID, instrumentation design systems, so on, are not mission critical, as I call it, for a plant. Mission critical, what I call mission critical systems, are like a DCS system. I have never seen a plant run without one, so you have to have that safety system, process systems. There are ERP, there are mission critical systems in a facility. However, if you look at those, you see that most of these mission critical systems have some kind of a need of this engineering data, engineering and design information. DCS, of course, they're looking at the control system data, the safety system, at the P&ID and process data, and so on and so on. So there is definitely, the engineering and design basis plays a critical role in mission critical systems that you have on a plant. So I mean, if the P&ID system goes down, the plant doesn't go down. If the DCS system goes down, the plant probably will go down. But the 1 and 1 is 3. If you have both of them up, I think you can leverage those information and capability to help you lower cost and risk. Now some examples. Now this particular maintenance guy in a plant in China, you see on the picture maybe that he has a little sniffer there that he holds up to the flange, and what he does is LDAR, leak detection and repair. So he has to go to the plant with his sniffer and collect the data and see if something is leaking, and of course if it's leaking too much, something needs to be done. So they use the P&ID as the roadmap for the plant. And you see, I don't expect you to read all the numbers, but the red little tags are the points that he has to go to with his little sniffer, and we can actually tell him then when, and keep track of it, and manage that he doesn't skip anything and does it all in time, and so on. So once he collected that information, he can do a risk-based inspection with the system out there. And if this thing is leaking too much, then it can actually be given to SAP, and a work order is issued to replace something, fix something, whatever is needed, and then update the design, and voila, you have the updated engineering and design basis for the next round of checks. But you can see here how the P&ID is actually helping managing and make sure that this LDAR is executed right. And it could also be a safety issue because there's something leaking that could be flammable. That's also another good thing. Instruments, very important. Instruments, of course, play a role in safety, like we just talked about the pressure safety relief valves, but they also play, of course, an important role in making sure that you have the right quality of product produced. It's check temperatures, levels, and flows, and what have you. So, but it can only check right if it's actually acting right, and you need to calibrate that. You see the guy with the little yellow box there. That's in this case a fluke calibrator. Now what you can do, on one hand you have the engineering and design basis, the instrument data, how this instrument type is actually, the specification of it and how it is being behaving. Now the nice thing is when you calibrate them and you upload it back in the system, you can actually do the what they call as found, as left, and you can see, of course recalibrate, but you can also see how this instrument is actually behaving over time, and that may give you the right information to make the decision that maybe this is not the right instrument for that particular task and replace it. So you have to do less calibration or be less of set points, as this particular solution you have right now. So that helps with safety, that can help with the product quality, it can help reducing cost, that you have to not, for instance, calibrate the thing every week or so. Another example is, of course, when you want to do some maintenance on a piece of equipment, you want to make sure it's isolated, electricity switched off, like I said before, and have a lock on it and a label and all that, but also the process, you have to turn down or close down all the block valves, and to find them, actually the engineering design base can help you to actually locate those, because when you have all the lines in an intelligent and connected way, you can actually navigate back from the equipment you want to isolate to the first available place to isolate it. Now safety, I told you already, there are all these standards out there. This is one, this ISO 10418 is dealing with safety systems on offshore platforms. And there are a whole bunch of rules in there. I mean, like this is just an example how they hook up a pressure safety valve and all the equipment around it. And this is just a procedure, but then this has to be translated in the design. So in this case, you have a vessel and all this stuff is around it, and how do you check that this is in compliance with these rules and stay compliant with these rules is that you can actually check that with some rules in the engineering and design base. So you can check the design. If you make changes, you can recheck it, make sure that it is still compliant with these standards. For instance, that you have the right components, the right piping, the right pressure setting. You don't want to have the pressure relief valve have a lower setting than or higher setting than the vessel. It blow the vessel before the valve opens. So that's not the intention of the protection. So once you check that, we actually can create these reports, and of course you see the green ticks and everything is fine, and the red ticks and something is not in compliance anymore, and you just have to check it, make sure that it is right and not discovered after the fact. That's not good news. So I gave earlier also examples. It's because I don't want to give the impression I'm only looking at P&IDs or so, but instrumentation, same thing. You can make checks that at the engineering phase, but also at the operational phase, that your engineering and design base is solid and sound. Same with electrical, of course. If you have the right cables and the right enclosures and what have you in the electrical design arena. I like this picture. I just put it in on the P&ID. I guess coming from the process side, I guess P&ID is one of my favorite. But this is a picture, and it looks like it looks okay. It looks like a cool. Engineers are, most of the engineers are, I guess, a little visual oriented, like myself. And you look at it at the first glance, and you say this is fine. But if you look twice, then you see actually that the PIs are nicely aligned. That gives you an impression that it is looking good, but if you look closer, you see that one has the check valve, directly after the discharge, and the other one actually has the check valve after the PI. So the location is different, and it's not right. So it's not consistent. So sometimes, when people make changes, you have to keep on checking if it's still correct with your practices and engineering practices. So you keep the design base right. And these rules, some people ask me, they said, yeah, that's all nice talking with these rules, but I'm not a computer scientist. Well, tell you I'm not either. So these rules are not so difficult to make. If you know what engineering is, if you know about engineering, anybody that knows that can make these rules. There's a simple way of just basically nesting all these questions into a simple user interface and make these rules. So you can make rules for your own practices, your own safety standards, and what have you. So this is, I just want to say that there is no magic involved here, and there is no, you don't have to have necessarily computer science course if you want to do this. And a lot of companies have done it. You see some that I listed here on the screen, engineering companies, owners that have used this type of checking. Anyway, another example is a company Bayer. Well, actually, this is their plant in Antwerp. They renamed their facility. This is a Covestro company, but it is the same method and the same thing they're doing. They use a web-based viewer to access the engineering and design base. So they can actually see P&ID, they can see the data sheet, they can see the loop diagram as you can see here. So what they like to achieve is, it's of course safety, reduce the search time. They got this little web tool, and they can do a simple query for the people out there in the field, and lower cost and of course super fast. And then of course they can initiate the notification to their ERP system, SAP in this case, to make some fixes. But the whole idea is that you have a single source, the engineering and design bases, that everybody can access using this web tool, and get the data to make the right decision at their fingertips. If you want to go to an instrument and unhook it or do something with it or replace it, then you can get the information to see, okay, if I do this, what can be affected, and what's the spec, and what is the wiring, and so on. Talk a little bit about safety. You see these guys, they discuss safety every time when they have an accident, which is not a good thing, after the fact. Actually, we want to do a little bit better and get going from a reactive type of setup, to a safe, sustainable operation excellent. That's what we want. You will see that, when you do that, your cost goes down and your production levels go up. So you need to put procedures in place and access to these engineering information in place to facilitate this road from reactive things like the two guys were just talking about the slide before, to a safe, sustainable, operational excellent. And it is definitely possible. Part of it is also people. You have to make it part of your culture, and you have to train. I understand that. That's a big part, actually, I think. But also in combination with that, you have to have the right tools. You have to have the right information to make that happen. You see here the OSHA 14 elements, a whole bunch of them. I mean, I'm not going to go all over those, but the bottom line is that there are solutions out there that can help you with these 14 elements. And it is about requiring access to asset lifecycle information. There's some is document management, some is 3D, some is the P&ID, some is training, but there are definitely components out there that can help you. And the engineering and design base is definitely one component that plays a role in, I would say, the majority of these 14 elements. Talk a little bit about safety. Now, everybody always talks about HAZOP, so I thought, okay, I'm not going to talk about HAZOP. So I'm going to give you another example. This is, you all probably have seen this type of drawings, area classification. It's also very important. It gives, on this 2D, normally it's a 2D drawing, it gives with these shapes and arching, it gives you an idea where certain time or all the time certain gases can be present at the plant, and knowing that you know what kind of enclosures or safety measures you need to take. You know, you don't want to light a cigarette in one of those areas. And the different standards, you know, the class 1, div 1, but you also got the European standards of, but it all boils down that you basically define the areas where there are basically explosion possibilities, and you want to make sure that you do the right thing. So I thought, okay, you know, we always made these things in, like I said, in the 2D drawings. When I worked at Fluor, the electrical department was responsible for these drawings. But I thought maybe we can do something smarter there using the engineering data. So I thought, okay, we can maybe do it in the 3D model, because it is a shape anyway. You know, it's not 2D. It's a certain area. It's not a flat thing, and you need to identify that, and then maybe it can help you to also make sure that you have the right enclosures and the right, you know, if you have to issue permits, that you know what's going on in the plant if you have that data right. So it's kind of sort of, again, using some rules as a watchdog to make sure it's the right stuff. So I'll show you a short little AVI on that. Now you see the 3D model and the P&ID. Now the piping guy is taking the valve from the P&ID to place it in this pump configuration. And with that, you know, you can not only get the valve, but you also get the process data and everything associated with that, and also the area classification area. Now, we can execute rules in the background. They're constantly running there as a watchdog, and say, oh, wait a minute. Based on these rules, and you know, you can set the dimensions. I chose a sphere. You can do any shape. So I said, okay, this sphere. In this sphere you have a certain area classification. Now the cool thing is you see that electrical panel there is now turning red. The reason is that electrical panel does not have the right area classification, not the right enclosure classification, I should say, for that particular area classification. So it turns red. So the rule said, wait a minute, you know, you're in that zone, you're not the right panel. So now you can do two things. You can buy a more expensive panel that is rated for that zone, or you can move it back to the other column outside the zone. You know, if you do it early on, you know, you have those options. If it's installed, of course, you don't have that option. Now the neat thing is that this sphere is actually related to the valve. So you see now it's green again as they change the rating of the panel. But the nice thing is when the piping guy is moving this set to the other side of the steps, the zone goes with it, and then the panel is again outside the zone, and you can go back to the old, you know, classification. And of course you can make the drawings out of it just like you did before with the nice arching. Even this one is in color. Another one is maybe a little different than you have normally seen, is this explosion impact. So you make the 3D model, offshore, onshore, doesn't matter. Of course, we have all these rules that I just said, so hopefully this minimizes any changes, but still we want to check for, you know, explosion impact. Now there is this company, Gexcon, I think they're coming from Norway. We made this interface with the tool. So we export the 3D model, they do their magic, and then basically we get feedback on what this explosion impact can do, and if you have to make some changes to your design. These people must have a great job, because they actually blow things up and simulate these explosions, and based on all these findings, they create these models, and you can see the colors, and so that they denote the speed of the gas and the temperatures and the pressure and what have you, and they use that in the analysis that they do. That's pretty cool. Now you see this, I like this particular picture of this offshore facility. You see that they simulated the explosion using the engineering and design data of the 3D model and of course of the process data. They use all that, and you see then with these colors and these shapes, when there's something happening at the wellheads, you know, where the pressure goes and the temperature is, and so on. And now you can make decisions on protection, on firewalls, on holes in the deck to let the pressure go away, because you don't want to blow off the living quarters at the end there. So, I mean, it gives you the right information to make the right decision in your design and so on. So I thought that was a pretty cool example. All right. So Ashley, let's do another poll question on what do you think about this?
Thanks, Frank. Again, everyone, please select inside the circle that best applies to you. Have you leveraged and integrated engineering data across different disciplines to support operations? No, we are not in siloed applications exchanging manually, or no, but we are working to do that, or yes, we have integrated, or you do not know. Again, we'll have a question and answer session here shortly, so please type your questions into your question toolbox, and I know Frank will appreciate your feedback on this, so this is your opportunity to let him know, and I'll give everyone a second or two more. Okay. I'm going to share the results with you. 44% of you said yes, we have integrated. 22% said you do not know. Another 22% said no, but we are working to do that. And 11% said no, we are siloed applications exchanging manually. Back to you, Frank.
All right. Let's see if I can get my slide back again. All right, so the last block, that's interesting. I'm actually, it's good news that I think there was 40% that already was integrated. If I remember correctly what Ashley said, that's actually pretty good. Still 60% that maybe has an opportunity to do something to help you in that area. I mean, there are many more examples. I just gave you a few that I thought were interesting and maybe a little different. So. But of course, there's a ton of opportunities to leverage that engineering data in your facility. All right. So last block is about information access. Of course, it is cool when you have all this information out there, but now you have to get access to it. And just like I gave the example of Bayer or Covestro in Belgium, they're using a web interface. I think it is nice when you have a tool that actually can give you access to that data. And you know, it is a combination of not only engineering data, but also in conjunction with, I mentioned earlier, the plant critical systems, like a safety system, like a DCS system, what have you. So that combination will provide you, everybody has data, but the combination provides you the right information, you know, in the context to do a certain job. You know, if you work on instruments, if you want equipment, if you do a turnaround, I mean, the view of the data, the information is different for the task. But if you have access to these different data sources and can basically consolidate that in that view, then I think you are a winner. So, for instance, you know, this is just an example where you see in the middle green block an equipment item, and then these little satellites around it will just indicate related information to that piece of equipment. So you can actually navigate from the equipment if you want to see, for instance, okay, show me all the instruments associated to it, or show me the P&ID, or see me the 3D model, whatever. You know, you have it all there on your fingertips, on your laptop or tablet or whatever you have there, coming from the single source, and you know, using the rules that I described, checked, and you can trust that information. That's important. Now, also, I wanted to show you one other thing. This is, believe it or not, this is a laser scan. It looks like a real movie. At first, when I saw it, I said, no, this cannot be, because I think laser scan must be like clouds, you know, cloud points. But no, this is a laser scan of a plant in Australia, and so there are really point clouds behind this, and you can measure things and all that good stuff. And you just saw this little guy walking around there. And if you don't have a 3D model, but you want to use it for these operational type of activities, you can very easily, you know, do these laser scans, and then you can interface with, in this case, this is a product from a company called Semansi in South Africa. that interfaces with the 3D model, and you can actually do operator training. You see all these hand wheels going red and green. You can let them do all kind of stuff, to train them and to also put them in unexpected situations, like you can create a fire, or you can, whatever, and then see what you can do. You can score them and so on. So, in short, if you don't have a 3D model of an existing facility, you can create this pretty easily using this laser scanning technology, and then you can utilize it for also operational tasks, like for instance operator training. But of course there are other things as well, that you can find stuff and locate stuff and plan stuff for like turnarounds and so on and so on. So I thought that was pretty neat. All right, so coming to the end here, I think that I hope I gave you some insight of what a solid engineering and design basis can do for you when you are in operations. Of course, you need to create one and be early on making sure that you have the right information at the end, and then have some rules to check it, not only in the engineering phase but also during the operational phase, so you keep your engineering and design base solid and trustworthy for all the tasks that you can do. And I think it can yield a tremendous benefit. You saw ARC talk about an average of 7 shutdowns. If you can reduce it to, like say, half, let's say you have only 4, which is also not good, of course, but if you can avoid 3 of them, of the 7, that is already a tremendous saving. Anybody that is an owner-operator, would have to agree with that. So you have to define up front your outcome that supports your business. All of the business drivers may be a little bit different from different companies, but be upfront, start early on, start at the end, and then you create this design basis, and I think it can be leveraged for many operational tasks. I showed you a few to definitely lower your cost and risk. All right, with that I came to the end of my little story, and I think we have some time for maybe some questions if there are any, and I'll try to answer it. If I don't have the answer, then I'll promise I'll try to find it for you.
Thank you, Frank. That was a great presentation. So one question that was presented is there a lot of programming to implement those training programs in a 3D model?
Yeah, a good question, and of course I heard that many times before. And excuse me, it is a program, a third-party program from a company in South Africa. But to do this programming of what the guy needs to do is just a spreadsheet. You have a spreadsheet, and you can enter, what you want this little avatar to do in a spreadsheet. There is no programming involved on the end user side at all. It's pretty cool. That's why I wanted to show it. I've seen it several times, and I've seen it in use with some customers. It's pretty cool how they do that, and how easy it is for the customers to put their training programs and their operational procedures that they want to enforce in this program using just a spreadsheet.
Oh, that's quite brilliant, because it gives you really a lot of opportunities. So that takes me to another question, is when you set up the rules to check a design, are you able to use those in multiple facilities, or do you have to create them over and over again?
Oh, that's a good question. No, of course, you don't want to create the rules and then use them and then throw them away. No, you can actually use them over. They're portable. You can move them between projects and so on, and between plans. And actually, the nice thing is that they with that concept, you can let them grow in in more comprehensive. You can start, for instance, with some rules that you say, okay, these are some critical things I want to check, and the rest I still do want to check manually or so. When you get more confidence, and you can add rules to your basically corporate rule base, and you keep on enhancing it and sharing it with projects and and plans. And when you start a project, you can, for instance, hand over instead of a big set of manuals with all your procedures, you hand them over this file and you said, okay, these are my rules, and just please check those first before you hand me over a set of engineering data for me to check, me talking as an owner. So yeah, definitely.
Okay, yeah, so that means that you don't have a lot of duplication of effort.
No,
so
no.
You reference P&IDs, and in a situation where they're not yet at that level of an intelligent P&ID, how do you develop? How do you develop an intelligent P&ID?
Yeah, that's also a question I get a lot. The people look at this and they say, well, that's pretty cool, but guess what? I don't have intelligent P&IDs. I just had PDFs or whatever. And there are many ways to get to an intelligent P&IDs. It depends. We had customers. There's one big plant in Port Arthur that decided to redraw all their 6,000 P&IDs in intelligent P&IDs, and they made the business case for that. But there are maybe other plants that say, no, we cannot do that. And we there are different opportunities. You can redraw them, or you can actually get the P&IDs as they are in the system, and then over time, add intelligence to them. For instance, you put them in the engineering and design base, at least you can get them in the same system to view, in the same system to correlate with other type of engineering tasks. But when you have like maybe a shutdown or a turnaround or whatever, you say, okay, for that unit, let me then add more intelligence to the P&ID, so you do it basically over time. Obviously, I'm not going to say that there are any miracles here. If the P&ID is totally intelligent, you can of course leverage more out of it than when it is like partial intelligence. But that is just a matter of where you want to spend your effort, your money, and where you see your business case for it. Some people said, oh, I'm okay if I have these stacks in there. I don't have to have all the process data, whatever. I have already made a big step forward of where I am. That's good enough. And of course, that's a lot less effort than when you said, no, I want it fully intelligent. I want all the process data in there, the pipe spec data, what have you, instruments and so on, all intelligent. So there are different phases and different possibilities to get from where you are to an intelligent P&ID.
Okay, that makes sense. So it's a process over time as you migrate into this utilization of this types of software. So
that's right, and I always say there need to be a business case. I can fully understand nobody wants to do something for the fun of it, and there need to be a solid business case for it, and that determines how you go about doing that. Sorry.
Yeah, that makes sense. So what you see on your screen right now is information about the 2017 Technology Conference, and many of the things that Frank brought up as it relates to the various aspects of the life cycle are going to be discussed and brought forward, whether it is case studies like Frank had or more of a futuristic hands-on demonstration. There is going to be a great opportunity for networking, and I hope that you will save the date on your calendar, go get more information. This takes place in April in Orlando, Florida, and we are thrilled to have plenty of exciting conversations, a lot of educational sessions that we believe are going to be not only titillating but applicable for use case and opportunities to continue to grow and expand your particular overcoming those challenges that constantly plague the areas that you might have a focus on. So we hope that you enjoyed today's webinar, and we thank you, Frank and Ashley, for being part of this presentation, and we would like to thank all those people who joined us. And stay tuned, there's more presentations to come. Next week we have an outstanding one as well. So feel free to check the FIATech website, and until then, we will see you later. Thank you very much.